Hello, this is Siraj. Welcome to this presentation on the basic concepts of information modeling in the context of business modeling and architecture. After this presentation, you should be able to define information and its characteristics, define models and their classifications, describe data model representation, especially in the context of object-oriented programming, and identify several modeling languages with a special interest in Unified Modeling Language or UML. Information is an increment in knowledge. It contributes to the general framework of concepts and facts that we know. Information relies on the context and the recipient's general knowledge for its significance. Information can be further refined, analyzed, and combined to make it even more useful and valuable as actionable knowledge. Data refers to individual facts or pieces of information, and information refers to data or facts that are assembled and analyzed to add meaning and usefulness. So data are only the raw facts, the materials for obtaining information. Information systems use data stored in computer databases to provide needed information. A database is an organized collection of interrelated data reflecting a major aspects of a firm's activities. For example, a single high temperature reading of an incoming patient at a clinic is one piece of data, but entered into the patient records information system and combined with patient's other symptoms and previous medical records, it becomes far more valuable as a diagnostic tool. Even more value can be obtained from this one temperature reading by aggregating it with the data from other patients entering the clinic on particular week. Tables and charts constructed from this data analyzed by geographic region may indicate a flu epidemic or the first signs of a pandemic emergency. As information from many clinics, emergency rooms, and doctors' offices pour in, and public health staff at the center of disease control analyze maps, patient diagnosis, and many other facts, a pattern may emerge that leads to swift action. Facts have something to say about the objects. Using a conceptual model and examination of relations and values of defined attributes reveal the facts. Some attributes with values identifies objects, while others help characterize them. A message, which is an element of information, is also about a certain fact contains values of attributes needed to identify and characterize an object. A quality of information depends on quality of processed raw facts. Then what are the major attributes of information quality? There are three characteristics that contribute to making some information very valuable. Timeliness matters a great deal in some settings, and real-time information often costs more. For example, people pay monthly fees to financial service companies to get up to the minute stock prices rather than delayed price reports shown on the free stock tickers. Accuracy of contents may seem like an obvious attribute for valuable information, but there actually are degrees of accuracy. The more accurate you want the information to be, the longer it may take to get it, making extreme accuracy a trade-off to timeliness. Completeness also adds value. However, striving for complete information may introduce delays that affect timeliness. Form is the level of detail, tabular versus graphic display. and quantity versus quality forms are selected in accordance with the situation, internal and external information. Most of the data captured by information systems relates to the operations of the organization itself, serving to produce internal information. But in an increasingly competitive marketplace, a firm needs to access more and more external information. Therefore, it is important to note that decision makers need both the internal information about their organization and the external information about its environment. A model is an abstraction or an approximation that is used to represent a real-life situation. Managers use models to represent problems to be solved. This in particular also helps to manage complexity, detect errors and omissions early in the life cycle, communicate with the stakeholders, understand requirements, drive implementation, understand the impact of change, and to ensure that resources are deployed efficiently. Depending on the subject matter and research perspective, models are classified several ways. There are defined types of models with relations and attributes. They are similar and have much in common. What is different is they have various purposes. In general, there are four basic types of models, namely physical models, narrative models, graphic models, and mathematical models. Physical model is a tangible representation of reality, such as a computer design and construction. Narrative model is a logical and descriptive, such as verbal and written descriptions, for example, reports, documents, and conversations. A schematic model is a graphic representation of reality, such as graphs, charts, figures, diagrams, illustrations, which are generally used in developing computer programs and systems. And mathematical model is arithmetic representation of reality, for example, solving mathematical models. In particular to this course, we can introduce four types of models, such as conceptual model, domain model, information model, and data model. A conceptual model defines what we mean when we communicate about our business. It is a composition of descriptive concepts of a system based on qualitative assumptions about its elements, their interrelationships, and system boundaries that help people know, understand, or simulate a subject the model represents. A domain model represents the things that exist or events that transpire in the business environment. This kind of model is a representation of meaningful real-world concepts pertinent to the domain that need to be modeled in software. Some essential features of a domain model include domain classes, attributes, associations between classes and objects, and business rules. A domain model generally uses the vocabulary of the domain so that a representation of the model can be used to communicate with non-technical stakeholders. An information model aims to describe what information an information system contains and what is communicated through its interface. It is a set of metadata. It is a set of metadata types that describe a tool, application, data structure, or information system. Information models are described by classes, relationships, and properties. Once you have created an information model for your content repository, you will be able to label information in ways that will enhance search and retrieval, making it possible for authors and users to find the information resources they need quickly and easily. The information model is the ultimate content management tool. Creating your information model requires analysis, careful planning, and a lot of feedback from your user community. The analysis takes you into the world of those who need and use information resources every day. A data model aims to describe how data is stored in an information system. A data model depicts the data flow and logical interrelationships among defined data elements. According to Hoverman 2009, a data model is a wayfinding tool for both business and IT professionals, which uses a set of symbols and text to precisely explain a subset of real information to improve communication within the organization and thereby lead to a more flexible and stable application environment. Data models are specified in a data modeling notation, which is often graphically informed. This can be sometimes referred to as data structure, especially in the context of programming languages. These are often complemented by function models, especially in the context of enterprise models. A data model instance may be one of three kinds according to ANSI, such as conceptual, logical, and physical. An object is the most fundamental type of concept. The object has an existence by itself independently of other concepts. When we think about certain phenomena, we need to categorize them and conceptualize them to give them meaning. Then we characterize an object by giving values to various object attributes and considering relations to other objects. The representation of data in a database of an information system is shown in three columns, such as entity, attributes, and attributes or parameters, and value. Here in database management system, an object is any singular and identifiable entity. It refers to individuals, organizations, systems, bits of data, or even distinct system components that are considered significant in of themselves. In this case, an attribute is a characteristic. It refers to a database component such as a table. It also may refer to database field. Attributes describe the instances in the row of a database. After two or more entities are identified and defined with attributes, the participants determine if relationship exists between the entities. A relationship is any association, linkage, or connection between the entities of interest to the business. It is a two-way directional, significant association between two entities or between an entity and itself. Each relationship has a name, an optionality, and a degree. Relations in a database are organized in a certain hierarchy, such as composition, association, and dependency. Here, dependency is a dynamic relation, association is a consistent relation, and composition is a whole part relations. The placeholder of an attribute contains a value, which is a string that should be filled in a prescribed format. For example, numbers, name of the employees, or locations. A value has a syntactical and semantical meanings. Syntactically, the value is symbolical, belonging to some symbol type, that is numerical, alphabetical, and graphical. On the other hand, semantically, the value denotes some phenomena the symbol intends to represent, that is, the meaning of the symbol. In object-oriented programming, we represent related attributes and methods as an object. So, for example, an employee could be an object within an application. An employee will have a name, email address, and password, as well as many other attributes. Within a database, this employee is represented by an ID. This means that the person could change their name, his or her name, email, and password, but it would still be the same person. When an object can change its attributes but remain the same object, we call it an entity. An entity is mutable because it can change its attributes without changing the identity of the object. The entity object will maintain the identity because it has an ID in the database. Modeling is an integral part of complex software system development projects. The purpose of models ranges from assisting developers and customers communicate to test case generation or automatic derivation of the developed system. A business modeling method is defined by business modeling language, the set of syntactic and semantic rules for building a set of diagrams and related objects constituting a valid model of a business system. A model can be developed by two approaches, bottom-up or top-down. Bottom-up process starting with throwing all classes on the page and then combining them, whereas top-down process starts with an overview of the system and then splitting classes. There are different modeling languages to create models to describe our business, such as Unified Modeling Language or UML, IDEFO, BPMN, Stanley, and so. ICAM definition for function modeling or IDEFO, which is a function modeling methodology for describing manufacturing functions. Business process model and notation or BPMN, which is a graphical representation for specifying business processes in a business process model. Stanley, which is a project under the Swedish Standards Institute organization, they drew up an interesting approach for information exchange of geographic-oriented information. The Stanley language was based on a binary view of information and included a number of facilities for expressing semantics. This language is still frequently used in Sweden. The basic principles of leading business modeling languages are quite similar. A great deal of concepts are common to most business modeling languages, though named differently in each language. The areas of such similarities include 1. Activities or tasks, that is the elementary steps of a process typically represented by a kind of boxes in a process diagrams. 2. Transitions or flows from activity to activity represented by lines. 3. Facilities to describe alternatives in a process, which is a kind of branching. 4. Facilities to describe activity concurrency, which is fork or joining. 5. Resources required to perform the activities, shown either in the same diagram or as references to a separate organizational diagram. And 6. Possibility to refine an activity by a sub-processes, which is a process hierarchy. However, the world of business modeling languages is characterized by the fact that there is no one leading or dominant business modeling language. No officially accepted standards exist in this area. This is in sharp contrast, for example, to object modeling, where Unified Modeling Language is strongly dominated. The Unified Modeling Language, or UML, is a general-purpose modeling language developed by Object Management Group, or OMG, which is intended to provide system architects, software engineers, and software developers with tools for analysis, design, and implementation of software-based systems, as well as for modeling business and similar processes. A UML diagram is a partial graphical representation of a model of a system under design, implementation, or already in existence. UML diagram contains graphical elements or symbols. UML nodes connected with edges that represents elements in the UML model of the design system. The UML model of the system might also contain other documentation such as use cases written as templated text. UML has many types of diagrams, which are divided into two categories. Some types represent structural information, and the rest represent general types of behavior, including a few that represent different aspects of interactions. These diagrams can be categorized hierarchically, as shown in this class diagram. Structure diagrams emphasize the things that must be present in the system being modeled. Since structure diagrams represent the structure, they are used extensively in documenting uh, documenting the software architecture of software systems. For example, the component diagram describes how a software system is split up into components and shows the dependencies among these components. Behavior diagrams emphasize what must happen in the system being modeled. Since behavior diagrams illustrate the behavior of a system, they are used extensively to describe the functionality of software systems. As an example, the activity diagram describes the business and operational step-by-step activities of the components in a system. A UML model consists of three major categories of model elements, each of which may be used to make statements about defined kind of individual things within the system being modeled. These categories are classifier, event, and behavior. A classifier describes a set of objects. An object is an individual with a state and a relationship to other objects. The state of an object identifies the values for that object or properties of the classifier of the object. An event describes a set of possible occurrences. An occurrence is something that happens that has some consequence with regard to the system. A behavior describes a set of possible executions. An execution is a performance of a set of actions, potentially over some period of time, that may generate and respond to occurrences of events, including accessing and changing the state of objects. UML was originally motivated by the desire to standardize the disparate notational systems and approaches to software design in 1994-95, with further development in 1996. The initial version of UML, or UML1, originated with three leading object-oriented methods, which are Booch, OMT, and OASE, and incorporated a number of best practices for modeling language design, object-oriented programming, and architectural description languages. In 1997, UML was adopted as a standard by the Object Management Group, or OMG, and has been managed by this organization ever since. In 2005, the Unified Modeling Language was also published by the International Organization for Standardization, or ISO, as an approved ISO standard. Since then, it has been periodically revised to cover the latest revision of UML, which is now UML 2.5. However, though well known and widely used in education and academic papers, as of today, UML is little used in industry, and most such use is informal and on ad hoc basis. The current specifications for UML is very comprehensive, which is almost 800 pages long. Therefore, in order to know details of UML specifications, I would like to recommend you to visit their website and read relevant papers and documents. Thank you so much for watching this presentation. Please feel free to leave feedback and contact us if you have any query. We really wish you a pleasant learning and good time. Bye for now.